if I were to draw a hand, let me just draw a hand really fast. So I'll draw a left hand. It looks something like that. That is a left hand. Now, if I were to take its mirror image, so let's say that this is a mirror right there, and I want to take its mirror image, and I'll draw the mirror image in green. So its mirror image would look something like this. It looks something like this. Not exact, but you get the idea. The mirror image of a left hand looks a lot like a right hand. Now, no matter how I try to shift or rotate this hand like this, I might try to maybe rotate it 180 degrees so that the thumb is on the other side, like this image right here. But no matter what I do, I will never be able to make this thing look like that thing. I can shift it and rotate it. It'll just never happen. I will never be able to superimpose the blue hand on top of this green hand. When I say superimpose, literally put it exactly on top of the green hand. So whenever something is not superimposable on its mirror image, let me write this down. So this is not superimposable on its mirror image. We call it chiral. We call it chiral. So this hand drawing right here is an example of a chiral object. Or I guess the hand is an example of a chiral object. This is not superimposable on its mirror image. And it makes sense that it's called a chiral. It's called chiral because the word chiral comes from the Greek word for hand. Greek for hand. And this definition of not being able to be superimposable on its mirror image, this applies whether you're dealing with chemistry or mathematics or I guess just hands in general. So if we extend this definition to chemistry, because that's what we're talking about, there's two concepts here. There are chiral molecules, and then there are chiral centers or chiral, well, I'll call them chiral atoms. They tend to be carbon atoms, so sometimes they call them chiral carbons. So you have these chiral, and then you have chiral atoms. Now, chiral molecules are literally molecules that are not superimposable on their mirror image. So, I'm not going to write the whole thing, not superimposable. Well, I'll just write the whole thing. Not superimposable on mirror image. Now, for chiral atoms, this is essentially true. But when you look for chiral atoms within a molecule, the best way to kind of spot them is to recognize that these generally, or maybe I should say usually are carbons, especially when we're dealing with organic chemistry, but they could be phosphoruses or sulfurs. But usually are carbons bonded to four different groups. Four different groups. And I want to emphasize groups, not just four different atoms. And to kind of highlight a molecule that contains a chiral atom or a chiral carbon, we can just think of one. So let's say that I have a carbon right here, and I'm going to set this up so this is actually a chiral atom, that the carbon specific is a chiral atom, but it's part of a chiral molecule. And then we'll see examples that are one or both of these are true. So let's say it's bonded. Let's say it's bonded to a methyl group. From that bond, it kind of pops out of the page. Let's say there's a bromine over here. Let's say behind it there is a hydrogen, and then above it we have a fluorine. Now, if I were to take the mirror image of this thing right here, we have your carbon in the center. I want to do that same blue. You have the carbon in the center, and then you have the fluorine above the carbon. You have your bromine now going in this direction. You have this methyl group. It's still popping out of the page, but it's now going to the right instead of to the left. So CH3. And then you have the hydrogen still in the back. These are mirror images if you view this as kind of the mirror, and you can see on both sides of the mirror. Now, why is this chiral? Well, no matter, and it's a little bit of a visualization challenge, but no matter how you try to rotate this thing right here, you will never make it exactly like this thing. You might try to rotate it. You might try to rotate it around like that and try to get the methyl group over here to get it over there. So let's try to do that. But if we try to get the methyl group over there, what's going to happen to the other groups? Well, then the hydrogen group is going, or the hydrogen, I should say, the hydrogen atom is going to move there, and the bromine is going to move there. But this has the bromine in, so this would be superimposable if this was a hydrogen and this was a bromine, but it's not. You can imagine the hydrogen and bromine are switched. And you could flip it and do whatever else you want or try to rotate in any direction, but you're not going to be able to superimpose them. So this molecule right here is a chiral molecule. And this carbon is a chiral center. So this carbon is a chiral carbon, sometimes called an asymmetric carbon or a chiral center. Sometimes you'll hear something called a stereocenter. A stereocenter is a more general term for any point in a molecule that is asymmetric relative to the different groups that is joined to. But all of these, especially when you're kind of in an introductory organic chemistry class, tends to be a carbon bonded to 4 different groups. And I want to stress that it's not 4 different atoms. You could have had a methyl group here and a propyl group here, and the carbon would still be bonded directly to a carbon in either case, but that would still be a chiral carbon, and this would still actually be a chiral molecule. In the next video, we'll do a bunch of examples where we'll look at molecules, try to identify the chiral carbons, and then try to figure out whether the molecule itself is all